Hey everybody, we're going to do some notes on concentration of acids and bases. So we learned what concentration meant in the previous section of notes, but let's just quickly review that. Okay, concentration is how much acid or base or anything, you could talk about concentration of sugar water, but how much stuff is dissolved in water. Okay, we've talked about this before. So how much stuff is dissolved in water? If it's lots of stuff, that is concentrated. If it's a little, that would be called dilute. Whoops. But we don't just have concentrated dilute, right? This is a whole spectrum. And so we have to be able to put a numerical value with the concentration. And the higher that value, the more concentrated something is. So we're going to use a value in chemistry. We use molarity, which is just a capital M as a unit, to express concentration. Okay, so capital M. And we'll just define that right here. Molarity. Again, capital M. We don't use a lowercase m, that's meters, okay? So molarity is the number of moles of acid or base or substance dissolved per liter of the solution. The number of moles of acid, base, or substance dissolved per liter of the solution. So 1 molar equals 1 mole per liter, or 1 mole per liter. Okay, we can write it a couple of ways, but 1 capital M, that's we would say 1 molar. So verbally we say molar. Okay, and that means 1 mole per liter, or 1 mole per liter, right? We can write the slash instead of the word per, or 0.25 molar. Okay, so again, capital M, we say molar when we're talking about it. 0.25 molar is the same as 0.25 moles per liter, which again, we can write that per as a slash, so we get 0.25 moles / liters. Okay. Okay, we're going to talk about making these solutions. So making solutions of specific concentrations can be simple. Okay, you can determine how much 1 mole weighs. And remember, we've done that already using the periodic table. So you determine how much 1 mole weighs using the periodic table. We're always going to have to do that. That is called the molar mass, right? Okay. Then you can dissolve 1 mole in 1 liter of water to make a 1 molar solution, right? We can keep it really simple. 1 mole in 1 liter is 1 mole per liter, which is 1 molar, okay? Again, maybe for later, you might want to put pronounced 1 molar, just so that you know what we're talking about there, okay? By dissolving 2 moles in 1 liter, you get a 2 molar solution. And it goes on and on like that, okay? The higher the molarity, the more concentrated a solution is. The higher the molarity, the more concentrated a solution is. You don't need to know anything else. All you need to know is the number that comes before that capital M. The higher that number is, the more concentrated the solution is. It doesn't matter how much solution you have. It doesn't matter what the substance is that's dissolved. It doesn't matter how many grams are dissolved. What matters is the number before that capital M. How many moles of substance are in the solution? The higher the molarity, the more concentrated the solution is. And then the other way around. The lower the molarity, the less concentrated or more dilute a solution is. Okay? There are limits to how much substance can dissolve. Okay, so sometimes, like in the sentence above, I said if you dissolve 1 mole in 1 liter, you make a 1 molar solution. Some things won't let you dissolve a whole mole into 1 liter. So there are limits about how much can be dissolved in water. These limits are different for each substance. In general, strong acids and bases, remember, strong doesn't mean the same thing as concentrated, but in general, strong acids and bases, that means they react quickly because they separate into their ions really easily, right? So they can dissolve more than weak acids and bases. Okay, so if you have a strong acid or a strong base, it splits easily into its ions, which means it will dissolve easily, which means more of it will dissolve in the water. And so they're going to dissolve more per liter than weak acids or weak bases. Okay, here comes a question. What if we don't want to make an entire liter of a solution? And that's a really valid point. Okay, we don't necessarily always need an entire liter of acid. The acid and base labs that we've done so far, we've worked with very small amounts of acids and bases, so we don't need a whole liter. Okay, so we will be making solutions using some common amounts that our glassware was made for. Okay, so you can't just make any amount because we don't have glassware that has every single increment of measurement on it. So we're going to use common amounts that our glassware was made for. For example, 500 milliliters, which equals half of a liter, okay, or 250 milliliters, which equals 0.25 liters, or 100 milliliters, which equals 0.1 liters. So those are really common sizes of glassware that we'll be using to make solutions. To make a smaller volume of a certain concentration, you must adjust the molar mass to match the volume you will be making. And by adjusting the molar mass, in the previous examples that we talked about above, we were dissolving an entire mole, which is the molar mass. We're not really changing the molar mass of the substance, but we are changing the amount that we need to dissolve. So we need to adjust that amount, okay? And I'm going to give you an equation. So equation you will need for this adjustment. I'm going to make it really big so that it stands out. And I'm even going to make it like a different color, maybe, if I can figure that out here. Let's see. Just because if it stands out more, you'll see it more. And you're going to be using this equation quite a bit in some activities. So here we go. Grams needed, whoa, not Grammys. Grams needed to dissolve equals molar mass times molarity, which the problem will tell you what molarity you want to make, times the volume in liters. So if they give you a milliliter volume, remember we have these three little segments here. These are the milliliter values you might see. If they give you milliliters, we have to change them to these liters to use in this equation. Okay, so grams needed to dissolve equals the molar mass times the molarity times the volume in liters. So now I'm going to adjust my font back to my regular size here and color. Give me a second. Okay. So we're going to go through some examples. Okay. First example, how do you make 250 milliliters of 1 molar NaCl? So 1 molar NaCl means that in a liter of this saltwater solution, there would be 1 mole. We only want to make 250 milliliters of it instead. Okay, again, we're going to use that red equation. We're going to use the equation that the grams needed equation. Okay, so I'm not going to use the red equation because you might not have written it in red, but we're going to use the equation to figure out the grams needed, and then we have to write a sentence. Okay, so use the equation to determine the grams needed, then write a sentence to answer the question. So people use the equation all the time, but then they don't write a sentence. Okay, so how do you make it? That's the question. Okay, so first off, the molar mass is the first part of the equation. We need that. So we're going to take sodium chloride, look it up on the periodic table. Sodium is 23.0. Chloride is 35.5. We add those two together, we get 58.5. Okay, that's the number of grams in a mole of sodium chloride. So that's our molar mass. Okay, the mass number, or sorry, the molarity comes straight from the question. Okay, the molarity is 1 molar, straight from the question. And the volume comes straight from the question too, but remember we have to use our volume in liters, right? So we have to change that to 0.25 liters. So here's our calculation here. Grams needed equals molar mass, so 58.5, times molarity, which is 1 for this problem, times the volume in liters. And we're going to end up with 14.625 grams. But that's not answering the question. Okay, if I say, how do you make banana bread? You don't say 1 banana, right? You have to actually give me the steps to make the banana bread. Now that's a lot more complicated than this one, but we have to actually answer the question. So my answer is going to be dissolve 14.625 grams of NaCl, okay, 14.625 grams of our substance in a certain amount of water. Can you think of how much water we want to dissolve it in? How much solution are we trying to make? Okay, so you could put 250 milliliters of water, okay, or 0.25 liters of water. But either way, that grams answer is only one piece of the answer. We have to put a whole sentence together. We're going to dissolve that many grams in the right amount of water to get the solution volume that we want. Okay? So don't forget to answer your questions that way when we do more practice. So here's another example. How do you make 100 milliliters of 0.5 molar NaCl? So we're going to stick with NaCl. Okay. All right. So again, Molar mass, it's the same as what we had above because it's the same substance. So 58.5, okay? Molarity in this problem, think about it. What's the molarity that we want in this problem? It is 0.5 molar, okay? And volume equals 100 milliliters, but remember we have to change that to liters. So 0.1 liters. So then we punch it into our equation. Grams needed equals, again, molar mass, 58.5 times molarity, 0.5 times volume, 0.1. All of that together equals 2.925 grams. That is not the answer though. I'm losing my page here, okay? So that's not the answer. We have to actually write our answer as a sentence. So here we go. Dissolve, wait, answer. Dissolve 2.925 grams of NaCl in 100 milliliters of water. So remember that volume comes from the problem. The grams needed to dissolve comes from our calculation. Okay, I'm going to change my margins here just a little bit, try and get this all on one page. And there we go. Okay, so now you're going to be practicing with that on the next activity, but thanks for tuning in and ask questions if you have any, but I will see you in class.